Welcome to the Micronaut podcast. I am your host, Sergio del Amo. I am here today with Markus Kett. Hello, Markus. Markus is the CEO of MicroStream and many other things. You organize also... How many conferences do you organize, Markus?
Yeah, hi, Sergio, and thanks for having me in your podcast. It's really my pleasure. Yes, I'm a co-organizer of the JCon conference, so I'm also co-founder and involved in the organization of the conference. But this is pretty much the only conference I'm organizer for.
There was recently an online JCon conference, but you are coming back in 2023 with an in-person event, right?
Oh yes, so we started in Düsseldorf. In Germany with the on-site conference in the multiplex cinema. Then during the COVID pandemic, we started an online edition. And this was so successful that we now keep the online edition, but we come back in June with the on-site conference in Germany. So the location is not defined, but we will be back in a multiplex cinema.
That's great. Let's start, before we talk about MicroStream, let's start by covering the agenda. So for agenda, so I know that MicroStream has been sponsoring and having presence in, and you have been talking in many conferences through the 2022. Do you have anything in upcoming before the end of the year on your end? Are you talking in any conferences?
So actually the talks are over for this year. So we will perhaps attend the AWS conference in Las Vegas, but only as participants.
Cool. Enjoy. That's, I believe it's end of the month. It should be reInvent, right?
So we will be there with our cluster team, because we currently work on MicroStream cluster, and this will also run on AWS.
Cool. So Marco doesn't have any upcoming talks, but they have a great YouTube channel. So if you go in YouTube and you search for MicroStream, you will find the official MicroStream YouTube channel, and they have many conferences, not just from Markus, but also from others in the team. So Florian as well. In the Micronaut end of things, we have 3 training events. We have Micronaut Data training event, which is next week. So we are recording this November the 3rd. I will probably publish the podcast episode on Monday the 7th. So if you listen to this in the morning, you will be still on time to register to the training that will cover Micronaut Data. Then we have another training event in November, which will be taught by my colleague Zachary Klein, and that will be November 14th until November the 17th. And last but not least, we will do a Micronaut Essentials. So that's kind of our introduction to Micronaut. That's great if you have people that you would like to get started with Micronaut for the first time, or you just have heard about Micronaut but you haven't really give it a try. That's we do it from the 12th of December until the 15th, and I will teach that myself as well. So hopefully we are able to see you in any of those events. You can register to those directly in the Micronaut website. So if you go to micronaut.io and you go to our events, you will find links to all those training events there, and we have also a professional training option in the menu where you will find those. And with the agenda out of the way, Markus, let's go to the main topic. In the main topic, so I told you already that Markus is the CEO of MicroStream, and if you have not heard about MicroStream, what is MicroStream, Markus?
MicroStream is persistence library, and so we call it micropersistent because it's very small. It's a Java library. You can include it into any Java project very easily, and it's for storing object graphs. So with MicroStream, you can store any kind of object graph, any size, any complexity into any persistence, into any data storage. Databases, plain files, even distributed caches or Kafka can be used as storage. And Vice versa, MicroStream allows to load any subgraph dynamically and restore it in memory when it's needed. And so this concept allows us to use the object graph in memory as an in-memory database. And so with Java Streams, we have a great query language that allows us to query and filter on object graphs. And searching object graphs with Streams API is super fast. So all operations are executed in microseconds. And by the way, this is also a reason why we call it microsystem, MicroStream. So because everything is microsecond query time, storage size, so everything is micro.
For anyone who haven't heard, the way I like to think about it is, so whenever you start developing a Java application, you probably don't start with a database, and you're just returning in your code just Java objects that you are hard coding. And the beauty of MicroStream is that essentially that's it. So you have your object graph, and you can just persist it, and upon application restart, it will work, right? So it's kind of a replacement solution for your persistent layer. So you can, instead of using a relational database, you just can have your Java objects and just persist them. And yes, all of us, we have experienced that when you work with Java objects, everything is incredibly fast. That's what you get. You can load a lot of, so maybe you are asking yourself, but do I have to load everything in memory? And as Markus said, you can load parts of your graph, so you don't have to load everything immediately in memory. So if your application has a huge persistence, and you're afraid every time you start your application, you're gonna have to load everything to serve the first request, you can load parts of the graph. The solution is built, is basically is kind of the concept of serialization in Java, but you wrote your own module, right? So it's kind of your own serialization solution that is using just Java, right?
Yeah, exactly. So we follow the system prevalence pattern, which means you keep the data objects in memory and use Java as a powerful programming language for data processing in memory, and everything we do in Java is super fast. And then using serialization to create a snapshot of your system state. This is the system prevalence concept actually, but creating a snapshot of your entire system state, this is not really working in practice. So with MicroStream, we only serialize and create a snapshot of the changes on your object graph. And we serialize the delta, only the delta is stored in a binary format persistently on disk. And the same vice versa, when we load data, we never, you can load your entire database into the memory. So this would work, but in practice, you only load subgraphs when they are needed with lazy loading. So then you never have to load your entire system state and recover your entire system state in memory. And this is why MicroStream is highly efficient and allows us to work with even huge storage sizes at the same time when you have only some megabyte memory. For instance, if you run a serverless function with only 512 megabyte of memory, so this will also work.
How old is the technology and the company that you built around the technology?
We started the MicroStream project almost 10 years ago when we worked on a visual Java development environment. So this was the initial idea. And to simplify and accelerate database programming, we worked on the JBoss Hibernate tools. We tried to simplify and accelerate it. But the problem is the core concept of object relational mapping is linked to many challenges. And so this is the reason why we started the MicroStream project 10 years ago. And almost 2 years later, the first companies use MicroStream in production. And then in 2019, we decided to found a company, build a company around the project, and launch the MicroStream as a software product. And then in last year, we have open sourced MicroStream. And then we were able to commit to the Micronaut project, and so this was a great milestone for us, very important, and so we are very proud to commit to the Micronaut project and being part of this Micronaut story. That's fantastic.
MicroStream is a sponsor of the Micro Foundation. We have a MicroStream module, which I will talk later more about. I just want to so MicroStream is being already used by many clients in production already for a long time. So this is not something that even it has been recently open sourced. The technology itself is solid and has been used by many clients in production for a long time already.
Yes, it's really production proof, and we used it for a long time in very business critical projects. And as I mentioned, it was a library that we used internally in production, but mostly internally for our projects, our customer projects, and it worked so great, and the numbers, the performance is so incredible. So when I saw the numbers for the first time, I thought this must be a mistake, because we measured actually not the performance of MicroStream. We measured the time. How long does it take to search an object graph with Java streams? And most Java developers say, I can imagine. So this must be really fast. And when we measured the performance, then we saw it's always microseconds. So no matter which complexity your object graph has, and no matter how many data you have in a memory, it takes microseconds. And this is around 1000x faster than a comparable JPA query. This is incredible. So we are wondering, how can this be true, and why is it not used in practice so far? And the answer is very simple. It's because there is no technology on the market to store an object graph as it is in memory. So in all of these databases, all databases, they use their own proprietary data structure or format. And these formats are not compatible with Java object graphs. So in any case, you need a mapping or a data conversion between your app and your data storage. And this is linked to latency. It takes mostly milliseconds, and with JPA, with the JPA approach, so if you use an object relational mapping framework like Hibernate, it doubles your query time. And this is the reason why traditional database applications with Java are often so slow. And with MicroStream, we do a shortcut. So we use the native object model, the memory model of the Java virtual machine. We use the object graph. So we can use all Java types. You can use collections, do whatever you like, whatever is possible in Java. And MicroStream will be able to store it and restore it in memory when it's needed. And this is actually the only thing, the missing piece of puzzle that MicroStream adds to the functionality Java provides. Object graphs, Java streams. So we're not forced to invent our own query language, because we have Java Streams API with Java version 8. So the perfect query language, it's type safe, fully object oriented, super powerful, and it's even faster when you run multiple CPUs. So with parallel streams, it's incredibly fast. It's unbeatable, and so this is the reason why we believe it's for many use cases a great solution if you need incredible performance.
So one of the things that you mentioned in the beginning, that the first time I heard about MicroStream was a bit confusing to me, is so you have like your application and you have like your data in memory. We all understand that. And then there comes the moment to serialize the data, right? And what Markus said in the beginning is, so you can serialize to disk. You probably will do that when you are like working in your local development machine. But if you are like deploying your application to a cloud, you can serialize and save it into something like S3, but you can also like serialize and save it to something like DynamoDB or your relational database. Even if you are not using, even if you are just using your DynamoDB as a kind of a place to save the data, right? That is decoupled from your instance that is running, right? But that's kind of like places where you can serialize and save your data into, but you are not like using the relational database API to query your data or anything like that. So that's kind of only like, that's like a storage solution, but the way you are querying your data is just as you are used to in Java, and as Markus said with the JavaStream API, which was added in version 8, which is fantastic. So you don't have to learn anything new. So for querying the language, you will use what you are used to, just Java way of navigating like collections and maps and things like that. And you just tell MicroStream, I want, when you serialize, this delta. So it's the way I like to think is the same as when you are like working with Git, that you are like saving the difference between your repo. This is kind of the same thing. You are like saving the difference between how the object graph was before and how it's after, and you just save it somewhere, and you tell MicroStream, I want to save my data to disk, or I want to save my data to this storage solution that I have here available for me, for example, DynamoDB or something like that. But it's not like you are using DynamoDB as kind of for anything more than persistence. One of the main things that you talk in, so the website of MicroStream is microstream.one, and you can find like the user documentation there. One of the key concepts is because this is an object graph, right? There has to be like a starting point of the object graph, right? Can you explain the audience what is the root object, and especially one thing important that, so when you are working with MicroStream, and especially when you are working in a multi-threaded application such as Micronaut, right? When you can have like multiple requests coming at the same time, when you persist, you have to like synchronize basically, so that is safe to basically save that, and you have to tell MicroStream which object do you have to save, right? If it's like a new object, what is the rule, Markus? Help me out. So if it's a new object, you have to save the owner. If you are like modifying an object, you have to save the object itself.
Yes. The functional principle is very simple. So there are no requirements to your classes, first of all. So just use plain Java objects, just Java classes, no annotations, no superclasses, no interfaces to implement. And this, by the way, is the reason, Sergio mentioned it already, we have written our own serialization from scratch. It's because you don't have to implement serializable. So you can use all Java types and serialize it. So we serialize only the delta, the changes on your object graph. And there is only one rule that's important, and this is you have to store the owner, which means if you have a collection and you change an object in your collection, you have to store your collection. That's it. That's everything you have to know. And you mentioned it already. So with MicroStream, you need a MicroStream instance. So the code to write is very simple. So you need a MicroStream instance and the root object. And all objects that are reachable from this root object can be stored by MicroStream, and by calling only one store method. And you as a developer, you decide when the changes are stored. So it's recommended to store always after there is a changing on your object graph, because otherwise you can lose data. So if there are any changes, call a store method, and then MicroStream serializes the changes and stores a new binary file into your file storage, which means we store all changes appended to your file storage. So we never overwrite data in a storage like relational databases do. So we store all changes appended to your file storage. So, and this is the reason why MicroStream is also transaction safe. So each store is an atomic none or nothing operation. If it's successful, you get a commit from the API. If it fails, actually nothing happens. So then there is a corrupt file on your file storage, but that's it. In the API, you will find a rollback for the object graph, and our file-based garbage collector will remove the corrupt files from your file storage to keep the file storage small. Yes, and so there are no requirements to your classes, no rules, but there is a paradigm shift, of course, a paradigm shift in database programming, because your object graph in memory is now your in-memory database. You don't query a remote database server. So this is changing with MicroStream. All queries are executed on your object graph, and because of MicroStream is not a database management system. Yes, you have to care for concurrency, but Java provides various solutions to handle concurrency. So we do not provide something specific for that. So this is the reason why we wanted to build a storage engine that is only responsible for storing and reloading your object graph, nothing else, not to become the next database management system. So Java provides everything actually we need to care for concurrency, and your business logic becomes your database management system.
I would like to talk about what we have built to integrate MicroStream with the Micronaut framework. So as the audience may know, we have, so Micronaut is a modularized framework, and we have many modules. And one of the modules, so if you go to docs.micronaut.io, you will find like a module pointing to MicroStream, and if you click that, you will find the documentation. So what we have done is a couple of things. So as Markus said, when you work with MicroStream, you have like to create like a MicroStream instance, and you have to tell the instance like, this is my root object graph. So imagine if you have like if you have like a bookshop, you could have like an object that has like a collection of books, and then has a collection of orders, and it has like some objects to track the inventory, right? So that will be like your root object. So what we have done in Micronaut is we support a Micronaut application that uses MicroStream to have like multiple instances. So if you want, for whatever reason, to decouple your instances and have one instance to do something, another one, you can do that. For a user, in order to use Micronaut MicroStream, you just have to add one dependency to your annotation processor class path. That's Micronaut MicroStream's annotation, and then another dependency to your compile class path, which is Micronaut MicroStream. We need the annotations once because we have some specific annotations which I will cover in a second. So once you add the dependencies, which, to be honest, the easiest way to add those dependencies, if you go to launch.micronaut.io, or if you are the person who prefers the command line tool, you go to our Micronaut CLI and you select the MicroStream feature, and those dependencies will be included for you. So once you have the dependencies in place, the next steps is configuration. So you have, as I was describing, you can have multiple entries. So you will have like something like MicroStream.storage.bookshop. That bookshop, you can call it whatever you want, and then you tell which is your root class, which basically you will specify the class name, so including the package. And that way we will instantiate a MicroStream instance for you, and we will tell like, this is your root class. So that's everything you have in place. Then you have, as Markus said, you have your object. You don't need any special annotations in place for using MicroStream. You can use the Micronaut annotations that you are used to in your pollos. So for example, if you want to generate at build time meta information about your pollos with the at introspected annotation, that's completely fine. That's compatible with MicroStream. There is no collision, no issues to use those. So that's, MicroStream really allows you to define your pollos as you are used to or as you prefer to. And then in order to save the objects, so in order to query, you don't have to do anything special. You just query as you are used to, with your JavaStream APIs, with your access patterns, as you are used to with when you are like programming and using Java in general. And then in order to simplify persistence, we give you two options. Either you can go low level, and we basically declare a bin of type storage manager, which is a class provided by MicroStream. So if you want to inject that bin in your controllers or in your singletons, you can inject it and use it directly. Or the other way, and that's my preferred way, is you use annotations, which they kind of basically simplify a little bit working with this. And we have annotations for essentially, as we were discussing before with Markus, whenever you change your object graph, you have to tell MicroStream to basically persist it. And we have annotations. We have an annotation called @store_return, which will store the return object of a method. And we have another annotation called @store_params, which you can use to store a parameter of a method. And what we will do is we will we have like a method interceptor, which will basically execute that method synchronized, so that you can like execute the logic in the method for basically, imagine you have a book and you are like changing the author of the book or the description. You just change the description inside the method, and then you just return the book, and you annotate that method with @store_return, and we will take care of synchronizing the method execution and telling MicroStream that they need to store a delta because the book has changed. And that's everything. Basically, you just have to think about that rule. Like you have to change, if you are like adding like an object to a collection, you have to save the collection. If you are like modifying, as I was telling in my example, like if you are like modifying something in an instance, you just have to install to basically save that instance. And that's it. And there is nothing more that you have to do. That's the magic. And one thing that you will probably want to do when you are like testing it for the first time, if you have to tell MicroStream where it should serialize that object graph. And the easiest way to do that is to like specify a folder in your laptop or in your computer. And that's, you will like specify something like microstream.storage.bookshop storage directory is my desktop, or whatever folder you want to do. And once you execute your application, you will see that MicroStream will save files there, right? So the first thing that you will do, because that's the first thing that every one of us does when you are using MicroStream for the first time, is you will save something in your application and shut down the application and start it again. And you will see that the data is still there, right? And that's the idea. So this is a persistent solution, and the data, of course, will be there upon application restart. One thing that, because this is not like a database, so you cannot use like a database graphical user interface to check the data that is being saved. But one great thing that they did is they provide like a graphical user interface.
Yes, this is a Vaadin application, and so it allows you to browse through your storage data.
So what we did is, so they have done one great thing, which is they have decoupled the graphical user interface from MicroStream, and you essentially will download like this graphical user interface in your computer. And what we did is we have another module called REST API, which will expose the REST API that can be consumed by your graphical user interface, and you will typically use this in development. And we have instructions in the documentation about how to add this to your application. And that way you can see how the object is being saved. And especially when you are learning about MicroStream for the first time, I will strongly recommend you to add this to your project, because that will give you like, it will click. So you will instantly understand how MicroStream is saving. We have like two things. So on the one hand, we have like the dependencies to work with MicroStream. Then we have an extra dependency to basically connect to this graphical user interface. And then we have a couple of extra things in the Micronaut MicroStream implementation. So we have integration with the health endpoint. So in a Micronaut application, in the moment you add the dependency Micronaut management, we will expose like a health endpoint. So endpoints in Micronaut are similar to Spring Boot actuators if you're new to Micronaut. So you can, the health endpoint in Micronaut, it aggregates several like health checks, and MicroStream will provide like a health check for each of your MicroStream instances. So in the moment you add that, that will be in place for you. And as I was saying before, we support like having multiple instances of MicroStream in a single Micronaut application. And if you have like 2 MicroStream instances in your Micronaut application, you will have like 2 entries in your health endpoint details. Another thing that we provide is integration with the micrometer metrics. So that's, again, if you are like using Micronaut and Micrometer and you're using MicroStream, that will be also included automatically. And the last thing is, so this is in terms of if you want to use MicroStream as your persistent engine. Then we have another thing, which is the cache solution. Can you, and this is, you can use in addition to using Micronaut MicroStream, or you can use just MicroStream cache if you want like to try it. And what will be the benefit for users to use MicroStream as the cache solution for Micronaut?
This part is perhaps a little bit confusing for some developers, because on one hand we go away from the object relational principle, and on the other hand MicroStream can be used as a JCache, and it's JCache compatible, and it's a JCache provider. Why? I mean, it was doable, honestly. So MicroStream is compatible to the JCache specification, and so it can be used as a JCache provider, and you can use it to replace cache in your Hibernate application, for instance. This is what we had in mind, because we still work on this open source visual development environment. It's called Rapid Clips, for building beautiful graphical user interfaces and accelerating database programming. And there we still use Hibernate and cache. And MicroStream is faster than cache, and this was the reason why we wanted MicroStream to have as also JCache provider. So that can be a drop-in replacement, so you can check it out if you like it, and if it works for you.
For those who have never used Micronaut Cache, so that's again another module of the Micronaut framework. But if you are like working with a database and some of your queries are slow, sometimes what you will want to do is like, I don't know, if you have like a newspaper, a website, and your news are not changing like constantly, you can cache some of the output of the methods. So typically what you will do is you will annotate some of your method with at cacheable. And we support, as Markus was describing, so Micronaut Cache is basically built on top of supporting JSR 107, so that's the JCache specification. And you can use either Cache, as Markus was saying, or Hazelcast or InfiniSpan. Another one that you can use is MicroStream. So this is a drop-in replacement, so you don't have to change any of your code. You just will use MicroStream at one of those. And the nice thing is that what you will get out of the box is you will get caches that can be restored upon application restart. Because this is like, if you have, getting back to the newspaper application, so if you're like caching and you, for whatever reason, you have to restart your application, the cache will be restored from the persistent solution of MicroStream. So that's one great thing that you get out of the box. The reason we added to Micronaut MicroStream is because we think it's a nice solution for cache, and also because I think it's a great kind of gateway drug and kind of like showing how easy it is to use MicroStream, and that is a technology that works. That my idea is that people will give it a try, maybe start with the cache, and then they see that this thing is great, this thing works, and then we can try it out for basically using as our persistent solution. And what people will see is that it heavily simplifies persistence in an application. And as Markus said, it's kind of a paradigm shift for all of us who grew like building applications with a relational database. We are like always like in our mind how are going to map these entities to the database and creating that list. This is kind of getting rid of all those constraints and just thinking, no, this is my object graph, like in Java, and I don't need to like think about how I'm going to map this thing to tables in a database and these two rows in the tables. So yeah, this is hopefully you can check it out. I wanted to point something else. So we have a Micronaut guide. So Micronaut guides, for those new to the podcast, are these step-by-step tutorials. I will include a link in the show notes. So I will include a link in the show notes to MicroStream and the guide. But basically, we will show you like how to use MicroStream to a Micronaut in combination to persist. And I think it will be like a really nice tutorial to do, and it's really like an only like 20 minutes commitment. You can do it in your lunch break, and hopefully this will be like something else to like the next time like you are considering a persistent solution for your project. You can think about MicroStream and Micronaut, and this, I mean, this will have like huge so one of the things is so on the one hand you save like development time because you are heavily simplifying persistent, but also it's like you are saving a lot of money as well. So one of the main things that whenever I talk to Markus, the things that your clients see is that they save a lot of money in cloud expenses, right?
Yes, that's true. And the reason is the performance of MicroStream. So the MicroStream core framework is built as a single node storage. And we also now introduce a Micronaut cluster solution. But even with MicroStream as a single storage, the performance is so incredibly fast that we can replace multiple traditional storage machines. So working with Hibernate and cache, for instance, and together with a relational database. So some of our customers, they save up to 90% of infrastructure costs because of one MicroStream machine in combination with Micronaut can handle the same workload as 10 or 20 traditional distributed nodes using object relational mapping and relational database. And with MicroStream as a cluster solution, there is even more potential to save CPU power and machines and infrastructure costs because of we use the object graph in memory as a in-memory database, which means our data are already in memory, and now we are able to replicate the object graph through even hundreds of JVMs, which means we do not need a distributed cache anymore. So most of these traditional database architecture, they use a distributed application nodes. They use a distributed cache for caching data, and they use a distributed database. And with MicroStream cluster, which by the way bases on Micronaut, we only need one application cluster. It clusters your database already, so you don't need a database cluster anymore. You don't need a distributed cache anymore. You only need a distributed Micronaut application, and this is generated by MicroStream Cloud automatically, which means with MicroStream Cloud, you will get a Micronaut distributed application out of the box. It will be generated automatically and the complete infrastructure. And you just deploy your Micronaut app and it runs as a distributed application or microservice. It can scale automatically. So we provide scale out, automatically scale out, scale in. So it's simple to configure, to provision your nodes and run Micronaut and MicroStream cluster. And there are only 3 main questions left, so we haven't talked about, but I think it's very important. So because most developers, they ask, okay, it sounds cool, but what happens if I change my classes?
Correct.
This is very important to mention, and here we provide so-called legacy type mapping. So no worry about that class changes. It's solved by MicroStream automatically through runtime, because MicroStream, if MicroStream loads an object, it always compares your object with your class. So if your class changes, MicroStream has a heuristic that can handle the simple cases automatically, which means if you add a field, rename or remove a field, it can be handled by MicroStream. For more complex cases, you can define a legacy type mapping, and then you store your object again, and then you have a new version of your object in your file storage. And MicroStream provides a kind of like file storage garbage collector that removes the older versions from your storage to keep your storage small.
The mapping is similar to, so for people like when you work like with a relational database and you are using something like Liquibase or Flyweight, like to keep track of the changes of your table. In Liquibase, you will typically create like an XML migration where you will say, I added this column to this table. In MicroStream is kind of the same, right? So you can create like a configuration that say this class change, I don't know, like I rename this string author to a string, like, I don't know, main author, and then I added this other string called secondary author, and you can like define, you can tell MicroStream how one field was renamed, right?
Yes. So this is very easy to use, very easy to handle. And so everything happens through runtime, so you never have to stop your application, refactor your entire database, and so this is very convenient and easy to use. We talked already about replication, so this is a new feature, and in combination with Micronaut, so we believe this is fantastic, and you built a great integration, so really beautiful integration, and so we can focus on the core functionality, and this is under the hood, storing and reloading the object graph and subgraphs when needed, and using Micronaut as a great framework to build the application logic and microservice logic, and so this was our intention when we built MicroStream. We built it on separation of concern, focusing only on our job, which is storing and loading object graphs. Nothing else. Everything is provided by Java or by Micronaut, and the combination is absolutely incredible. Fantastic.
Is there anything else that you think we should mention before we wrap it up?
Conclusion is really performance is incredible. It's a paradigm shift in database programming, but the good news are it's much easier because all of other technologies you have to learn new things. With MicroStream, you don't have to learn new things. It's core Java. Everything is based on core Java. The biggest challenge for developers is not to think as a database programmer. So don't think about relational. What do you have ever heard about relational databases and tables and columns and constraints? Think like a Java developer. Think object oriented. Then it's the way. It's the way to go. You can do everything with Java and trust Java. Use everything that Java provides, and MicroStream will be able to store and to reload it. And the slowest part of MicroStream is input-output. So when we access the disk, of course, But it's highly efficient, so it's much faster than relational databases in terms of storing data and loading data because of our high efficient serialization. It's pretty much the same performance of your infrastructure. So you will get out the max of your infrastructure. It's very easy to implement, no requirements to your classes, just POJOs, no interfaces to implement, core Java features. It's for Java developers really fun to develop it. It's fully object-oriented programming model. Yeah, and together with Micronaut, a great solution for building applications and microservices.
As Markus said, so don't be intimidated. So it is a paradigm shift, but it's not like you don't have to learn a ton of new things. It's mostly like changing the way you think, and this is kind of same thing that when you delete code that you no longer need. This is kind of the same thing. So it's like how to build applications that use a relational database, and suddenly you realize that there is a technology that allows you to build applications without that part, which is great. So I will include link in the show notes to learn more. So I encourage you to visit MicroStream.one. Also to check out the YouTube channel of MicroStream if you are kind of the person who likes to learn using videos. I know like if you register to the MicroStream website, you will have like a ton of video resources there waiting for you. And I also encourage you again to visit the MicroStream documentation and the MicroStream guide. And before we wrap it up, let me thank the sponsors of the Micronaut Foundation. This podcast is possible thanks to the Micronaut Foundation's sponsors. So many thanks to Object Computing, which is the ambassador sponsor of the Micronaut Foundation. Many thanks to MicroStream, which is a silver sponsor of the Micronaut Foundation, to -Q and Safri.net, and Visor Games, all of them bronze sponsor of the Micronaut Foundation, and also to Gradle Enterprise and JetBrains, both who are tools and infrastructure sponsors of the foundation, and to Oracle, which is an engineering partner of the Micronaut Foundation as well. So many thanks to all of them. Without the sponsors, the development and the advocacy of the framework will not be possible. So thanks to all of those. And I would like also to thank Markus for joining me today for this episode. I was lucky to see Markus in person a couple of weeks ago in Prague. And that's always nice to meet someone in flesh after all these online meetings. So many thanks, Markus, for joining me today. Is there any place else that you would like to point people to learn more about MicroStream?
On our website, MicroStream.one, you can find great documentation and examples, and also the code is on GitHub. And on GitHub, we also have a bookstore demo. You can check it out and try to implement your own queries and can see how MicroStream works with full text search, with Lucene, for instance. So this is what many developers ask for. How can I build indexes comparable to relational database indexes? So you can do whatever Java provides. So, and there is an example, you can check it out. You can build your search service with MicroStream and Lucene together. And if anything is missing in MicroStream, check out the great Java ecosystem. Almost everything is there. So if you want to have allow third-party applications access to your Micronaut, MicroStream application, you can use GraphQL, for instance. So you can combine almost everything that's provided by the Java ecosystem and build great applications. And to wrap up, for us, it's thanks for having me, Sergio. It was fantastic, and thanks for the opportunity to talk about MicroStream. And for us, it's fantastic to be able to give something back to the Java community, to work on open source projects, And by the way, most people ask, how do you earn money? So it sounds great, but how do you earn money? So we provide this cluster solution. This is proprietary software, and with cloud solution, software as a service, we earn money. So this is the reason why we can really open source the complete framework, complete open source MicroStream, and give it to the Java community, and talking about conferences. This is our passion. So, and very, very important for us. And the best currency for us is give us feedback. So if you check out MicroStream, give us feedback, start us on GitHub. And so thanks to the community, and thanks for having me.
I would like to wrap it up with so one thing that Markus said. So MicroStream is open source. I'm going to include a link in the show note to the GitHub repo. MicroStream has been sponsoring many conferences through this year, contributing a lot back to open source, not just in terms of like them open sourcing their code technology, but also like sponsoring a conference, which without the sponsors of conference, the conference will not be possible with the attendees ticket price. So many thanks. Thank everyone for listening to this episode, and we listen to each other soon. Thank you.